Majestic Major, a model aircraft project. This one is part 2. Removing the existing servos and testing my Futaba FP-9ZAP transmitter with a suitable PCM receiver. The radio installation in this plane was diabolical. I removed the old servos and the rails that supported them. Just one heavy landing or catching any of the control surfaces whilst transporting the plane could quite easily have dislodged the position of these servos, so the whole thing had to go. This clip shows me unscrewing the servos from what's left of the support rails. I'm not going to use either of these servos that were in the plane to start with. I'm just going to put them in my box of old servos. It's a good idea to keep servos, you can use them occasionally for spare parts. These rubber grommets used to hold the servos in place were very badly perished. And as usual, the brass eyelets were fitted the wrong way round. This is very common in radio control servo installations. I found things in this box that I didn't know I had, a piston, and a prop nut and a prop driver. And I really don't know where these came from. This is my box of old servos, and as you can see there are quite a few and most of them are damaged, or the very cheap servos that I don't use anyway. For the installation in the Majestic Major I'm buying new servos. I'm only rummaging through the old servo box to find some that work so I can test the receiver and the transmitter. And talking about receivers, I found this one. This is a high-tech. I think I bought it for my yellow submarine, but never used it. In a box in a cupboard I found this. It's a Spectrum DX7 transmitter, and it's the radio set that I use with my quarter-scale laser yacht. Here's the old battery that I upgraded in this transmitter. I'm going to go through all of my batteries because some of them just want thrown in the bin. I mean, look at this one. The dreaded black wire syndrome strikes again. This is a strange phenomenon that affects black wires on batteries. I'm actually going to dispose of most of these batteries, including this low-capacity one. A few years ago I bought this. It's a really good charger. It charges lithium polymer batteries, nickel metal hydride batteries, nickel cadmium batteries, and even lead acid batteries. It's fully programmable to charge and discharge batteries. I find this incredibly useful. Some people don't get on with programming, but I do. I knew that my early life as an apprentice electronics engineer would come in useful. I'm lucky really, I have the type of brain that locks into stuff like this. I seldom read manuals, I only read the manual if I get stuck. You can program this unit to charge batteries at different rates and of course select different types of batteries to be charged. It even tells you when there's an open circuit on the output. I have a couple of interesting batteries. One is a brand new one that I bought about, 8 years ago. It's a 6-volt receiver pack, and the larger battery also is a 6-volt receiver pack with a much higher capacity. It even has a Tamiya connector on it as well. Generally speaking, I like to use higher capacity batteries because there's less chance of them going flat when you're using them, and by using 6-volt batteries instead of 4.8-volt packs, the servos are more powerful and move faster. I'm going to mount the servos in the Majestic Major installation using one of these. These are Futaba servo trays, and if mounted properly inside the aircraft or boat or whatever you're putting them in, the servos are very securely held in place. This battery charger has the facility to allow charging and discharging of batteries. It's called cycling, and it can improve the performance of the batteries. The battery that I'm about to discharge and charge over a few cycles is the one that normally lives in my laser quarter-scale yacht, where it powers the receiver, the sail winch and the rudder servo. And now for something really good. This is my transmitter. I've had this for many years, and yes, it was very expensive. At one time, it was Futaba's top of the range. Its official name is the FP-9ZAP, and it is a thing of great beauty. They were very expensive when they were new. This machine is utterly programmable. You can make it connect anything to anything else. And look at the build quality. It even has a plug that goes in the charge hole. I bought this second hand a lot of years ago. I drove from West Yorkshire down to Middlesex, paid the man £350, put it in the car and then drove back. This thing is built like a tank. It uses military-grade components. I've had a look inside it and it's a masterpiece. It also has something called a CAM pack facility, so you can back up the model data to a removable device. If I wanted to be critical about this machine, I couldn't be. It gives me a warm and fuzzy feeling looking at it. Even after all these years, you have to feel at the thing to get the idea of how good it is, a bit like one of my past girlfriends. This is a modular device and you can insert different modules in the back. This is a Spectrum module which converts the transmitter to 2.4 GHz operation. As well as this, I have a couple of 35 MHz modules and even a couple of 40 MHz modules. Here I'm removing the 35 meg module just to check that the frequency is what it says on the flag. These systems are not like the modern 2.4 gig ones. You have to use a matched pair of crystals in the transmitter and the receiver to lock them together, pretty much like the binding system on 2.4 gig, but a good bit cruder. And the transmitter cannot change its frequency. Whichever crystal you use, that's your lot, that's the frequency that you're transmitting on. To change the frequency, you just change the crystals in the transmitter and the receiver. On top of the aerial on my transmitter is a piece of ribbon, and this is there for three reasons. One is, it shows people where the end of the aerial is so they don't poke their eyes out. The ribbon is very useful when you fly a model aeroplane. It tells you which way the wind is blowing. And it's somewhere to stick the frequency number so you know which frequency you're flying on. This receiver is a 40 MHz receiver used for controlling model cars and model boats. Model aircraft have a designated 35 MHz band. This particular receiver is a dual conversion FM receiver, but I don't use these much. I prefer the PCM type. PCM stands for Pulse Code Modulation, and this is a 35 MHz PCM 1024 receiver, and I'm going to use this in the Majestic major aeroplane. What's so good about PCM, you may be thinking? Well, let me give you an example. Here I've plugged the battery into the receiver without switching on the transmitter. And if you do this on a normal radio control system, the servos are likely to chatter, and the worst case scenario if they're in an installation is they could break the linkages in your model by moving radically out of control. In this clip, the transmitter's not yet turned on and the servos aren't chattering. When I switch on the transmitter, the servos move into the required position. I find the PCM system to be really good because not only is the receiver waiting for a signal from the transmitter, it has to be the correct type of signal before it does anything. The receiver will not lock into the transmitter unless it sees the correct PCM code. And now as I move the sticks on the transmitter, the servos all move proportionately. I fly in a different mode to a lot of people. I have the throttle on the right and the ailerons on the right. The elevator and rudder are normally on the left, but because this aeroplane doesn't have any ailerons, I'm going to also link the rudder control on the transmitter to make it so that the left-hand rudder stick also moves the rudder too. This will be good for two reasons. Normally when I'm taking off, I would steer the aeroplane on the ground using the rudder, and once airborne I would use the ailerons and elevator to turn the aircraft. The rudder makes the aircraft yaw and therefore turn. And once it's in the air, I can use the aileron stick to move the rudder. This Futaba ZAP-9 is the complete answer in my opinion. Here's a servo testing facility built in. Oh yes, I almost forgot, a ZAP-9 has a tachometer built into it as well. This servo test can be very useful for testing the battery in your airplane. As all the servos move together, the current drain on the battery is considerable. And after a half-hour test using this system, you know that your flight battery's fine. And there you have it. I just need to buy 4 new servos and I think I will buy a new battery. It's a small price to pay to make sure that the aircraft's installation is as safe as it can be. And that's it from me. I still don't feel very well. It may be a reaction to the COVID injection I had 10 days ago. My ex-wife and I both had our injections on the same day and she also has the same symptoms as me currently. But look on the bright side, it's better than getting COVID-19. Stay healthy, thanks for watching and I hope you found it useful. Please take the time to visit my Mainstream Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.